Have you ever noticed the colorful red-purple residue that forms on a plate or bowl when you eat frozen blueberries? I want to share with you something interesting I have noticed when I washed this residue out of my bowl. Okay, I'll go over here to my sink where I can rinse the reddish residue with water from my tap. Watch carefully now. Oh wow, did you see that? The reddish residue undergoes a color change to blue when I add tap water. Isn't that interesting? I've seen this color change happen many times when I rinse the dishes I use to eat frozen blueberries. Maybe you've seen it too. Let's test to see if distilled water, which is essentially pure water, causes the same color change. I'll add a bit of distilled water to this separate bowl that also contains frozen blueberry residue. We don't get the same color change to blue when we add pure water. What do you think that means? I'd guess it means there's something in my tap water that causes the color change to blue. My hunch is that it is dissolved minerals in the tap water that is causing the color change. Water that contains dissolved minerals is called hard water. The compounds in hard water often contain calcium ions and magnesium ions, and these could be chemically reacting with something in the blueberry juice. To test this idea, let's add some mineral water to the blueberry residue. Notice that the minerals in this brand of water supply calcium and magnesium ions. Okay, first I'll add some pure water. And now I'll add the mineral water. Hey, look at that! The color change induced by the mineral water looks very similar to the change caused by the tap water. I think we might be able to try some further tests that could tell us whether it is calcium or magnesium that's causing the color change. To do so, I'll just add some frozen blueberries to this styrofoam bowl, top it with another one, and shake it up. There! Looks like the bowls have been coated with the red-colored blueberry sauce. Time for our first test. I'll first add some distilled water to this bowl. To test if magnesium ions cause the color change, I'll dissolve in some Epsom salts, which contain a compound known as magnesium sulfate. Doesn't look like there's a color change. I guess it's not magnesium ions that are causing the color change. Because ice melter contains calcium chloride, we can add some of it to see if calcium ions cause the color change. Would you look at that? The ice melter initiated a color change to blue. I think this is some good evidence that calcium ions interact with something in the blueberry residue to cause a color change. I'm going to do one more test to see if it's calcium that's causing the color change. We all know milk contains calcium, so let's add some milk to see if any free calcium ions in the milk can induce the blue color change. Hey, it looks like it worked. That's pretty neat. Scientists have actually learned how this red to blue color change occurs. You see, pigment molecules called anthocyanins impart pink, red, blue, or violet colors to fruits, vegetables, flowers, and plants. As you can imagine, blueberries contain a lot of anthocyanins. Anthocyanin molecules are known to chemically react with various metal ions such as aluminum, iron, and calcium. And sure enough, when anthocyanins chemically combine with metal ions, they change color. Anthocyanins also change color when they react with acids and bases. To learn how you can do some of your own experiments using anthocyanins found in red cabbage, check out the Exploring Acids and Bases experiments by visiting scifun.org. Well, I hope you enjoyed learning a little bit about the pigments in blueberries and how these pigments can change color. Thank you for watching.